let's look at the basic matrix operations, and one of those is equality. So two matrices are equal if they have the same size, so the same number of rows and the same number of columns, and their corresponding entries are all equal. So one example here is that matrix A is equal to matrix B because they have the same number of rows and columns, and the entries in both matrices in the corresponding row and column are equal. So we have 1 is equal to 1, 0 is 0, minus 2 is equal to minus 2, and 4 is equal to 4. Now matrix B is not equal to matrix C because B has 2 columns and C has 3 columns. Now the next basic operations are addition and subtraction. So again, the matrices must have the same size, otherwise you cannot add or subtract them. So as we can see, A plus B is valid because both matrices have the same number of rows and columns. So if we added these matrices together, we just sum the corresponding entries. So 1 plus 1 is 2, minus 2 plus minus 2 is negative 4, 0 plus 0 is 0, and 4 plus 4 is 8. And similarly, B and D have the same size, so we can also do B minus D. So that'll be 1 minus 1 is 0, minus 2 minus negative 2 is 0, 0 minus x is negative x, and 4 minus 4 is 0. So we can't sum A and C because A has 2 columns and C has 3 columns, and we can't subtract C from B for the same reason. Now the next basic operation is the scalar product, which is multiplying a scalar or a number by a matrix. So basically multiplying the scalar by the matrix is the same as multiplying the scalar by every entry in the matrix. So for example, 2 multiplied by A will give 2 multiplied by 1 is 2, 2 by negative 2 is negative 4, 2 by 0 is 0, and 2 by 4 is 8. And a special case is multiplying negative 1 by a matrix, which simply negates the matrix. So effectively minus A is the same as negating all those elements. So I have minus 1, minus minus 2, minus 0, and minus 4. Now our final basic operation is the trace of a matrix, which is written as follows, and this is only defined if A is a square matrix. So effectively the number of rows is equal to the number of columns, and it's the sum of the entries on a diagonal. So effectively the trace of matrix A is 1 plus 4, which is 5.